we started last time for this example, and we have 3 reactions, which are enough. So we have this cross. That means this truss is internally indeterminate. First, second step, we need to remove the extra unknown. Your extra unknown will be one of these 2 diagonals. So I decided to remove this one, member AC. So your truss became like this. Go ahead and solve this truss due to the given load after you removed the extra member. So I solved my truss due to the given load by joint equilibrium and find the internal forces in each member, which is called capital N. The next step, please go ahead and remove the external load, 6 kb and 8 kb. Remove them and remove all external forces and put the extra unknown that you removed in this step. I removed this member. Okay, go ahead and put this member equal unit load. And solve this truss one more time. The internal forces in this truss called small n. We covered all this stuff last time. Then I'm going to set up this table because I have equation delta 1 node plus R, delta 1 equals 0. Delta 1 node means summation small n capital N times L over AE. Delta 1 summation n square small n square L over AE. So I set up this table. If you remember, the first column members, the second column capital L, the length of each member. Third column, what is the internal forces, capital N. Fourth column, what is the internal forces, small n. I need to multiply this column by this column by this column to get N times L, and I got my summation, 134.4. Then I need to get this column square times this column to get N square times L. Please note these equations. And I got the summation, which is 17.28. So if you substitute these values in this equation, you can find 134.4 over AE plus R times 17.28 over AE. This value and this value can be cancelled with 0. The only unknown in this equation is the value of R. What is the value? What is the meaning of value of R? Go back to the first step in this problem. I removed this member AC, and I put the force in this member like this, tension 1, tension 1. Your value is negative. That means the force in this member is compression, not tension. It's opposite because we have negative. And the internal forces in this member, 7.8 compression. I'm sorry. All of these calculations, all of these steps from the start, the first step until you set up your table and get these values and get the value of R only to get this, the forces in this member only, yes. Then we need to get or to solve that truss, final internal forces. Okay, go ahead. At this moment, I can make a equilibrium here for this joint, for example. We have 8. We have horizontal member. We have vertical member. We have inclined force with 7.8. I believe I can solve for this joint equilibrium because we have only two members only. So I can apply summation f of x equals 0, summation f of y equals 0, so I can get the forces in this member and this member. I can do joint equilibrium here. I can get my reaction. I can make joint equilibrium here. So I can solve this truss for the third time. But the third time solution can give you the final internal forces. So I would like to confirm something. This method, which called consistent deformation method, only will help you to find only the value of the extra unknown. Only value of the extra unknown. Once you get the value of the extra unknown, your structure or your truss became determinate. Go back to chapter 3 and resolve this truss third time. So Oliver, your question is, what is the meaning of R? If R is negative, if R is positive. Positive or negative, your assumption is correct or not correct. But what is the meaning of R? R is the value of the extra unknown. Once I get the value of the extra unknown, I need to resolve my truss one more time to get the final answer. Let me do another example. If you didn't catch the first one, please pay attention to the next one. We have a truss, indeterminate truss, indeterminate. And we need to determine the internal forces in each member. Okay, first step. First step, I need to figure out this truss is internally or externally indeterminate. You have to ask yourself one question. Do you have cross? Do you have cross members like this in this truss? I don't think so. Okay, one more question. How many reactions do you have? We have one here. We have one here. It's roller. We have two here. It's a hinge. So how many reactions? We have 4 reactions. Actually, 3 reactions are enough. That means we have 1 extra reaction. That means this truss is externally indeterminate. Second step. Okay. Okay, thank you. Second step. Go ahead and remove this extra unknown. That means I'm going to remove member or reaction. I'm going to remove reaction because I have extra reaction. Here is your truss. I will not change anything. We have 2 options, I believe. The first option, you can delete this reaction, or you can delete this reaction. It's up to you. Both of them works. Actually, I'm going to keep this one and keep this one, and I removed this reaction. So I removed the roller. And we have 6 kilonewton, nothing else. Third step. So the second step, I removed the extra unknown, which is a reaction in this case. Third step, solve the truss after you removed the extra unknown. Your truss looks like this. after you removed the extra unknown, and we have 6 kilonewton. Go ahead and solve this truss due to the given load. I think this joint has 2 members without any external forces. This member will be 0. If you make joint equilibrium at this one, because this one is 0, this one will be compression, -6, and this one will be 0. If you make joint equilibrium here, this one will be in tension. How much? I think 6 divided 0.6. It's 10, positive 10. And this one will be compression. How much? 8, -8. If you make joint equilibrium here, this member will be 0. The internal forces in this truss called capital M. I'm sorry I did it quickly because I will not repeat all of these steps one more time. You learned these steps in chapter 3. You learned them in virtual work during deflection, and this is the 3rd time. So you should be more professional in solving truss. Okay, what is the next step? Step number 4. Remove all external forces and put the removed unknown equal unit load. Guys, I will remove the external forces. I removed the external forces, and here is your truss. Can you remind me what was the extra unknown that you removed? You remember it? Yeah, I remember. I removed this reaction. I removed this reaction. Please put this reaction equal unit. 1 kilonewton. And solve your truss one more time. Solve your truss one more time. I think this one will be compression. I think it will be 1 divided by 6 equal 1.67. This one will be tension, I believe 1.33. If you make joint equilibrium here, this one will be compression. This one will be tension. I think 1.67 times 0.8. This one will be 1.33 negative. I think this one will be 1, probably. 1.67 times 0.6. Yeah, 1. If you make joint equilibrium here, this one is tension, this one will be compression, this one will be in tension, this one will be 0. So I think 1 divide 0.8. Oh, no, wait. 1 divide 0.6, 1.67. This one will be 1.67 times cosine 0.8. Yeah, times 2.67. These internal forces can be called small n. All of these internal forces only. D2 unit load value for the extra unknown that you removed in step number 2. Any questions so far? Okay, Brock, what's your question? Is it your question, Dr. Ayman? That's it? member EB. Which member EB? Why? It's the intention. No, it's the compression. Why intention? Try this joint. We have horizontal force, we have vertical force, we have this member and this member. That's right. With this member already done from this joint and this member already done from this joint. So this one in tension, this one in tension. If you are trying to search this member will be tension or compression, go ahead and imagine the vertical component of this member must be down or up. What do you think, Brock? What do you think? I'm talking about this member. That's right. So this force, which is 1 for the vertical member, I'm trying to search for something make equilibrium with this one. So I believe the vertical component of this force must be down. That means this force, the force in this member must be in this direction. That means this member will be in compression. You agree? Okay, so this member will be in compression. Okay, if you are trying to search what is the direction for this member, okay, we have this one in this direction, and this member, the horizontal component will be in this direction also. That means this member will be in the opposite direction, which is tension. Okay? Anyway, last step, which is the most easy step, we need to set up a table. The first column in the table, I'm sorry, is the member. Please put all members, don't forget any. So what do you have? We have member A, B, B, C, C, D, D, E, E, A. So A, B, B, C, C, D, D, E, E, A. What else? We have B, D, and B, E. We have B, D, and B, E. What is the length of each member? 4, 4, 5, 4. 4, 4, 5, 4. I think EA will be 3. Yes. And then BD 3, BE 5. What is the capital internal forces? What is the small internal forces in each member? Okay, go ahead and put your capital N, negative 8, 0, 0, 0, negative 8, 0, 0, 0, 0. We like 0. Then negative 6, positive 10. Negative 6, positive 10. What is the small n in each member? 2.67, 1.33, 2.67, 1.33, negative 0. What else? We have positive 1, negative. This one is negative because it's a compression. 1, negative 1.67. Go ahead and set up another 2 columns. The first one will be small n, capital N, L, small n square time L. So if you multiply the first one, 4 times negative 8 times 2.67, your value will be negative 85.4. This one will be 0, 0, 0, 0. We like 0. 3 times 6 negative times 1 equal 18 negative. The last one, 5 times 10 times negative 1.67. Don't forget any sign. Will be negative 83.5. So the summation for all of this stuff will be negative 186.9. Then go ahead and get a small n square times L. So 2.67 square times 4. This value will be 28.5. 1.33 square times 4. This value will be 7.1. 1.67 square times 5 equal 13.94. This one will be 7.1. This one will be 0. This one will be 3. This one 1.67 square times 5 will be 13.94. Get the summation value of 3 plus 7.1 plus 13.94 plus 7.1 plus 28.5. Your summation will be 73.58. So delta 1 node plus R delta 1 1 equals 0. The first term will be negative 186.9 over AE plus R. The second term, delta 1 1 equals 73.58 over AE equals 0. I can remove this one and this one by 0. The only unknown in this equation is the value of R. The value of R will be positive 2.54. This value, after all of these calculations, only value of the extra reaction. It's a value for the extra reaction. So your final truss, something like this. We have a roller here. We have hinge here. We have a roller here. And we have 6 kilonewton. What you solved until this moment only, you got the reaction 2.5. Positive means you assumed the correct direction. You assumed this direction is the correct direction. So this reaction is 2.54 kilonewton. Go back and solve for the remaining reaction. Okay, let's start. If you take moment at this one, so 6 times 4 minus 2.54 times 8 divide 3 . This reaction will be in this direction 1.23 kilonewton. If you apply summation f of x, this reaction will be 1.23. If you apply summation f of y, this reaction will be 6 minus 3.46. I think I can start to make joint equilibrium here. This member will be in compression, and this member will be in tension. I'm trying to solve this truss for the third time, which can give you the final internal forces in each member. Guys, the issue is we have extra unknown. This extra unknown stopped me to solve for the remaining unknown. So I was waiting to get the value of the extra unknown. Once I get the extra unknown value, I can solve my structure like I learned in chapter 3. I figured out the reactions from summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I can solve for reaction. Once you get your reaction, go ahead and solve for the internal forces in each member. For example, this one will be in compression. How much? It will be 4.23. This one will be 3.38. Keep going until you get the internal forces in each member. So I would like to confirm a very important information, which is this method will not solve your truss, but this method will help you to get the value of the extra unknown, the extra reaction force, or the extra member. Once you get the value of the extra member, your truss looks like that one you learned in chapter 3. No, Oliver, no. You need, because the problem asked to determine the force in each member. The problem didn't ask to get the value of the extra unknown. So you need to get the full credit of this problem. You need to solve your truss for the third time. You are at home. You can get a cup of tea and solve your exam. No, you have to solve your structure to the end. You have to solve your structure until you get the final internal forces. Last example, we have a truss. We have truss, looks like this. We need to determine the internal forces in each member, but this truss is indeterminate. Yeah, I can solve for reaction because we have only 3 reactions. One here, it's roller. 2 here, it's a hinge. We have 3 reactions. 3 are enough. But we have another issue. We have cross. That means this truss, which is the first step, this truss is internally indeterminate. Second step, I need to remove the extra unknown. Because your truss is internally, we have issue with the members, so I need to remove one of the members. Any member? No, not any member. One of the cross diagonal. One of them. Go ahead, any one of them will work. So your truss looks like this. I kept everything. Then go ahead and decide which one you need to remove. It's up to you. both of them the same. So, okay, I will keep this one. And I removed member CE. I removed this member, CE. Third step, solve the truss for the first time. It was a given load. Your truss looks like this. We have here 24. We have here 24. We have roller. So I will do it quickly. This one is 8. This one is 6. So this one will be 10. So I can figure out the sine and the cosine. Anyway, I have two reactions here. One of them 0. This one will be 24. This one will be 24. If you make joint terms, this one is under compression. This one in tension. How much? I will tell you. 24 and divide what? Divide 0.6. This one will be 40 negative. Time 0.8. This one will be positive 32. The same here. This one will be negative 40, and this one will be in tension 32. This one will be 0. I can do joint equilibrium here. This one will be under compression. How much? 40. 40. Time 0.8. Yeah, 32 negative. And 40 time 0.6. This one will be 0. You are lucky. So this one is 0. This one will be 0. Okay. From joint acrobium. So this one will be under tension also 32. That makes sense. This one is capital N. This one is 0 because I have 3 members. 2 of them are collinear, no external forces. So this one is 0. This one is 0 and this one is 0 from calculations. We don't have specific situation for these members. This one and this one. They are 0 from calculations. Fourth step, remove any external forces and put the extra unknown that you removed equal unit. Here is the truss after you removed the extra unknown. And I removed the external forces, 24 and 24. Can you remind me what was the extra unknown that you removed? Yeah, I removed the member CE. This member, I removed this one. Okay, go ahead and put this one equal unit. 1 kilonewton. And solve your truss one more time to get small n. This reaction will be 0. This one will be 0. This one will be 0. This member and this member 0, 0, 0. This one will be 8. Yeah, 0.8 negative. This one will be negative 0.6. This one will be the same. Negative 0.8. This one will be negative 0.6. This one will be tension 1. Here is the internal forces, capital small n. Once you are done, go ahead and set up your table. Member L, capital N, small n, and let's do it. AB, BC, CD. EF, FE, EA, EE, CF, and two diagonal, CE and BF. Guys, don't forget to put the member that you removed. What is the L of each member? What is the capital N of each member? Okay, we have positive 32, positive 32, positive 32. We have negative 40, we have negative 32, we have negative 40. Then 0, 0, 0, 0. The member that you removed, CE, will be 0 capital N because you removed it. And this member that you removed will be 1 as a small n because you put it 1 here. Don't forget this. And put the value of small n for each member and go ahead and apply delta 1 node plus r, delta 1, 1 equals 0. Add here 2 more columns to figure out the value of delta 1 node, delta 1, 1, and get the value of r. This value of r is the internal force in member that you remove, in member CE. Once you get the value of internal forces in the extra unknown, I can resolve the truss for the third time to get the final answer. So guys, what do you think? It's not hard method, but it takes more time. Okay, we don't have issue with time because we have enough time. Like we did last exam, time isn't issue. Became not issue in our exams. So we can solve this method in our exam. We have 2 problems in your homework, the same sequence. Let's try to figure out the first one. What do you think? You should have more experience right now. So I can say, hey, this truss is externally indeterminate. Why? You said it externally without any calculation. Yeah, because I don't have cross. If you don't have cross diagonal, your truss will be externally indeterminate. Try to figure out to remove extra reaction. Go ahead. We have reaction here. We have reaction here. We have 2 reaction here. So I think the best scenario, you can remove this one or this reaction. For the second problem, without any thinking, this truss is internally indeterminate. Why? Because I have cross. Actually, we have 1 reaction and the 2 here. So we have 3 reactions. 3 reactions are enough. No more, no less. 3 reactions are enough. So don't do anything with the reactions. We have cross, so we have to remove one of these 2 members. This one or this one. Here is the homework.